Hello dear friends, welcome to my channels. Today's discussions is topology gate 2012. Let x equals to a comma b comma c and let x is equal to phi comma a comma b comma a comma b comma x be topology and defined on x. Then which of the following statement are true? P. X comma tau is a Hausdorff space, x comma tau is a regular space, x comma tau is a normal space, and x comma tau is a connected space. So friends, now we have to know the Hausdorff space definition. Points x and y in a topological space, x can be separated by neighborhoods if there exists a neighborhood u of x and a neighborhood v of y such that u and v are disjoint. Okay, so u intersection v equals to phi. X is a Hausdorff space, and if any two distinct points in x are separated by neighborhoods. Now we know the term definitions. Okay, what is the regular space? In topology and related fields of mathematics, a topological space X is called regular space if every closed subset C of X point P not contained in C admit non-overlapping open neighborhood. Thus P and C can be separated by neighborhoods. Normal space. A topological space X is normal space if given any disjoint closed sets E and F, there are neighborhoods U of E and V of F that are also disjoint. Connected space. A connected space is a topological space that cannot be represented as the unit of two or more disjoint non-empty open subsets. So friends, I hope I give all the definitions for your understanding. Let's start our problem. Let's solve our problem. What is our problem? Our problem is x equals to a comma b comma c and tau equals to, okay, in here question it is tau, okay, tau equals to and a comma b comma x. Okay, so friends, x comma y belongs to for all. Now for p, question number p, for all x comma y x, and there exist g1 comma g2 belongs to tau such that this is the condition of the Hausdorff space that x belongs to g1 and y belongs to g2. Okay, and g1 and g2, according to the g1 and g2 is the open set. Okay, neighborhood means open neighborhood. Okay, u is the g1 is g2 is neighborhood u of x and neighborhood of v. Okay, so is neighborhood of x and neighborhood of y. Okay, so neighborhood generally we take open set. Okay, so g1 intersection g2 equals to phi. That is the Hausdorff space. This is called Hausdorff's Hausdorff Now let x equals to a and y equals to c. A and not Hausdorff space, and G1 equals to A, okay, and G2 equals to X. So G1 intersection G2 does not equals to phi. Similarly, you can check for also B is also including in here in the questions according to the question ABC. So and G2 is equal to, if you choose B, then easily you can get that intersection G1 intersection G2 is equal to A does not equals to 5. So all the element, so we cannot show this kind of Hausdorff space, we can't show. So P is cut, we cut P. Number is regular space. Okay friends, regular space. So I go to the definition. What is regular? In topology related fields of mathematics, topological space X is called regular space if every closed subset C of X and point P not contained in C admit non-overlapping open neighborhoods. Thus P and C can be separated. So simple. So whatever I get X is equal to, no post for Q, X is equal to phi A x comma tau, and for tau nbd, tau neighborhood tau closed subset, okay, closed subset f, tau closed subset f, and for all p does not belongs to f, then okay, then G1 and G2, so this is a regular space, means that closed subset F and P does not belongs to F, then there exists G1 comma G2 belongs to tau, okay, so G1 and belongs to G2 belongs to tau, such that if subset of G1 and P and G1 intersection G2 D2 equals to phi. This is the normal space. So we choose that P equals to A. So what is the closed set? Closed set of A is equal to B comma C, A comma C, and C closed set, and open set is I write open set is equal to phi A, and this is B, this is AB, A comma B, and this is X. Okay, so this is open set. So closed set and open set. So G1 intersection G2 does not equals to X, and G2 equals to A, but G1 does not equals to phi, so it is not regular. Okay, regular space. So according to the definition, C closed subset C of X and point P not contained in C admit non-overlapping open neighborhoods. Thus P and C can be separated by neighborhood. Question is Q is not regular space. Okay, now x comma tau is a normal space, so we need to know what is the definition of the normal space. A topological space X is normal space if given any disjoint closed sets E and F, there are neighborhoods U of E and V of F that are also disjoint. So friends, whatever you get x comma tau x comma tau for all there exists a closed set disjoint normal, means f1 f2, there exists g1 and g2 belongs to tau. So f1 subset of g1 and f2 subset of g2, but you cannot see this assertion. Okay, assumption. So assumption is false. Okay, assumption is false, so it is normal space. Now S is, it is connected space, it is obviously connected, as regular Hausdorff space is not, we never see Hausdorff space. Okay, Hausdorff is any disjoint set we never get. Okay, a connected space is topological space that cannot be represented as union of two more disjoint non-empty open sets. Okay, you never get any disjoint non-empty open disjoint set. So I hope it is clear. Now please check my total work. Okay, my total work is this. Thanks for watching.